Welcome to the Bryden Wood Podcast. Bryden Wood is a global strategy and design consultancy. We are inventive thinkers, designers, engineers, and technical experts. We integrate creativity and deep experience to resolve complex challenges and realize a better world. Find us at brydenwood.com.
Hello all, and thank you for joining this edition of the Bryden Wood Podcast. This edition, I'm delighted to be joined by Jon Guidroz, Senior Vice President of Aalo Atomics. Jon, welcome to the podcast.
Thanks for having me on, Jaimie. Great to be here.
No, thank you ever so much for joining me. As usual, perhaps we can start with a quick canter through your CV, your journey to Aalo. So I know you started in the energy sector. You've then worked with some of the big tech companies with a focus on energy, and now into Aalo. So perhaps you can sort of quickly talk us through your career.
Yeah, sure. I mean, maybe I'll start in the middle. About 12 years ago, I joined Amazon, large technology company, actually from the traditional energy sector, to start an energy vertical inside AWS. And so the intent there was sort of contemplating how cloud and hyper scale computing could really play a role in delivering this energy transition that was bubbling about in the public narrative. And we did a lot of good work there, but through that journey, I learned the importance of sort of marrying a platform level compute with actual energy solutions. And I'll talk maybe more about what I mean by that. Then I went on to Google and did a similar role at Google Cloud. And about 5 years ago, I went to Microsoft, where I became the Chief Strategy Officer of the Energy and Resources team at Microsoft. And, you know, I'm sort of neglecting the first bit of my CV, but I'll come back to it. I think what's probably most interesting to your audience is about 2 years ago, almost 3 years now, I got into a sort of thought space of how I get more directly aligned into the impact of delivering this sort of just energy transition at a global scale. And I really zeroed in on advanced nuclear as a space that needed to be successful, and began asking, you know, what's missing from that recipe that needs to be true. This ultimately led me on an interesting secondment to a nonprofit called Terra Praxis, who I understand Bryden Wood has worked very closely with. So we stood up
Friends
a partnership.
podcast, yeah.
On the podcast,
Yeah.
exactly. So listeners, go have a listen to that episode. You'll learn all about that mission. And I thought Terra Praxis had a very clear set of thinking and principles around what needed to be true, and a strong point of view on how those things needed to come together. And so we stood up a partnership between Microsoft and Terra Praxis. So I was a part of that team that initialized that partnership. And through the partnership between Microsoft and Terra Praxis, I went and invested 8 months on an interesting civic leave of absence program that Microsoft has. That allowed me to go deeper on a global level and really get some exposure to where the solutions were falling short and where folks were making great leaps and bounds on the technology side to deliver, you know, DFMA, design for manufacturing and assembly, the types of things that Bryden Wood has advised and consulted around. And it got me quite excited about joining one company in particular where I am now, called Aalo Atomics, which is a small nuclear modular factory-based scale-up play. I neglected the first part of my CV, Jaimie, if I may just sort of go back to it.
Please do, yeah.
What's probably interesting to pull through there is I grew up in South Louisiana state, right, southern United States, in a city called New Orleans, birthplace of jazz. New Orleans is a great place to visit culturally, but if you had a time machine and went back 70,000 years ago or so, there would be just open water, right? There's no bedrock there. It's a river delta. The Mississippi River there runs right through. And as a result, it's sort of ground zero for climate change impact, and at least in the United States. So I grew up as a 9th generation Louisiana resident, very proud of our culture, very passionate about the wetlands, where we spend a lot of time fishing and enjoying the great outdoors. And I've watched that change extremely rapidly just in a short childhood into adolescence. So we lose about a football field every 45 minutes of land in Louisiana, for example. And so thinking about how we could address climate resiliency as sort of a reality behind climate change, actually adapting to the change that's unfolding outside of our control at this point, as well as bringing around solutions that could maybe slow down some of the dramatic pace of the climate change impact, has been really core for me. The other thing is Louisiana is an energy state. It's quite an oil and gas patch. If you go just off the coast there, I grew up fishing around many oil rigs and platforms where production is. And there's always been this juxtaposition of that being sort of an interesting ecological negative impact, many canals and, there's sort of degradation associated with the production of oil and gas for sure. And on the other side, there's also coastal restoration efforts that are funded by it. There's these structures in the ocean that attract fish and serve as a food chain for housing fish. So you go fish around them as an interesting place to sort of like an artificial reef almost. And so that really got me thinking about how both erosion and creation can play together, and how energy plays just this profound impact. The other piece is, when I was in my mid-20s, I went and spent a year backpacking around the world before there was a reason to do so because of social media. And I spent a good bit of time in places that are considered energy poor. So I don't know, there's about 1.2 billion people, I think, today living in what's considered energy poverty. And those folks don't have access to clean water. They oftentimes have very little access to power, if at all, maybe a little bit of light during the day or ability to charge a cell phone. I traveled through many of these places and spent a lot of time there, did some volunteering work as well. And it just became undeniable that energy underpins prosperity, well-being. It also underpins the ability to be a good steward of the environment, right? When your needs aren't met, there's some drastic actions by humans to survive and thrive. So we must have a clean, firm, scalable energy source that's dispatchable across both the developing world, the developed world, et cetera. So long-winded response to what my background is, but I think that, the first core truth of me is that I grew up in a place that understands energy and is trying to get out of the old way, and is also impacted by the consequences of climate change. The second truth is I've seen a lot of the world where energy poverty is still a reality. And so wealthy countries must have a way to meet their demands. And I'm sure we'll get into AI and my work at the tech companies, but we also must pull the global south. I don't know if you can see behind me the south-oriented map. We must pull the global south and the rest of the world out of where they are currently. Otherwise, we certainly won't serve the greater human good nor the environment and slow down climate change. And then the third core truth that took me a minute to get there is that, and I imagine many of your listeners are this as well, I'm a technology optimist. So I really believe that technology and innovation is this embodiment of human creativity. And when it's done well, it's not just a tool, but like a reflection of our capacity to solve problems and build a better world. And so that's one of the questions that drives me. And I think you and I have in common, Jaimie, is I like to think about how we design systems, energy systems, which really philosophically are like an externalized version of our mind. We augment our mind, we augment our physical work with energy, we augment our sustenance and farming and ability to produce food. And so all of this maps back to resiliency, living in an equitable society, a sustainable society. Folks say living in harmony with nature, but I think it's also a deep, profound realization that we are in fact nature itself, and so we must live within it. So I'll stop rambling in just a moment, my opening salvo, but the big mission for me is like, how do we untether humanity's impact from our ability to grow and be a part of this earth? And spoiler is that this just happens to turn out to be Aalo Atomics' mission where I am today.
Yeah, but it's incredible. So when when you joined Aalo, I know you put a post on LinkedIn explaining the move. So listeners, if you're interested, it's a fantastic piece of writing, I think, anyway. But yeah, really outlining. We've talked on this podcast before about energy security for data centers and the importance of dispatchable energy. I think that no one's talked about it in quite the same way about the really taking that humanist view of saying, yeah, there's an entire generation or future generations coming up. I think you made the point in your written piece around that the most energy secure and richest countries have a tendency to say, well, we're fine. It's the next generation of countries that have the responsibility to stop using so much energy. And you go, no, that's not right. We can't do that. We have to, as you say, I think you use the phrase, how do we decarbonize the rich world and fuel growth while being fair to the entire world as they improve their standard of living, was one of the phrases I took out of your piece. So I think that's like a fantastic sort of world view of saying, actually, yeah, data centers is one part of it, energy security is one part of it, but we are trying to solve the needs of future generations, and coming from a sort of very personal place. I think that's an incredible sort of like broad outlook to have that we haven't seen before, haven't talked about before.
Yeah, thank you for that. I'm quite passionate about that view, and it's really something that's developed over the course of a decade or so. When we began the partnership between Microsoft and Terra Praxis, it was really a rally cry around repowering coal, and it still is and should be focused on that, right? This is a massive impact that needs to be offset, and we can't just grow clean energy production without addressing that piece of the story. So I still think that's a core mission. But the reason I step back and remind myself of that context is that we didn't really fully appreciate yet how much data center growth and AI in particular could be the tip of this demand spear that would drive the economics that I think ultimately unlocks that. So this clicked like, oh my gosh, there's a mirror staring, reflecting straight back at me, the tech sector. We were there sort of saying, how do we apply software and interesting sort of compute solutions to help build the business case and scale up around repowering coal facilities. And then it was just there looking straight back at me. Actually, the tech sector is willing and able to pay a bit more for the electrons. And we can get into sort of why that is. There's a spread between the value of a compute bit and the value of an electron in most markets, right? And if that tech demand can, in fact, drive the order book, as we say in nuclear, drive the demand side to bring the investments, to bring the paradigm shifts about, the true adoption of DFMA and other things like that, modularization, then it can go serve the broader market, and we can achieve things like incredibly inexpensive clean power that's easy to dispatch into parts of the world where there may not be transmission infrastructure built yet, or we're still burning firewood as the primary source for cooking, which has its own sort of pollutive capacity to it, right? So I thank you for the question, and I do think that while it may seem, we're sort of Tesla selling to the luxury market and promising one day we'll unlock, I'm very mission driven to get to the unlock, and I just think it's a once in a generation opportunity to do that.
Yeah, I really like your technological optimist comment. I think it's fascinating that maybe in 10, 15 years we'll look back and one thing that the internet and data center will have done is sort of change the way that we engage with technology and information. But actually, if that's the thing that solves the energy crisis and actually bizarrely solves climate crisis, that would be a phenomenal outcome. We have talked on this podcast before about the idea that data centers are an incubator for certain things, and if we can propagate them, then that becomes the kind of test case for lots of things that can have wider application. But this is maybe the biggest sort of topic that we've talked about yet in terms of maybe it solves the climate crisis. That would be a phenomenal thing that you'd have helped to propagate. So because I'm sort of quite interested in that journey that you're you've worked in big tech companies, but it's got this incredibly personal sort of driven mission that sits alongside it. You've mentioned Aalo a couple of times. We've talked about it. Perhaps you can actually explain what Aalo does, because I think they are driving some of this stuff at a pace that the industry really needs at the moment. We've talked a lot about the need for small modular reactors, but Aalo's really starting to make some inroads. So perhaps you can explain that a bit.
Yeah, Aalo Atomics is really born out of I would say a blending of circumstance. I call it the Goldilocks soup of things all beginning to happen. Many of them, most folks knew needed to become true, and there's sort of this swirling tailwinds around opportunity space. So I think Aalo is in part timing, but secondly, a big technology investment that we're leveraging is the Department of Energy in the United States ran a program called Marvel, which is the first advanced reactor that was licensed for construction by the Department of Energy in over 3 decades. So you have this technology readiness specific to a reactor program that's pretty interesting. And behind that is this thesis that we can move from, and I may be echoing something that I suspect you've already spoken to in other episodes, but this thesis that we need to move nuclear from projects that are bespoke to products that are repeatable. And there's sort of like, you can get in a room with a lot of people and they'll say, yes, we know that has needed to happen for a long time, but it hasn't happened. So why is the paradigm shift now possible? And we have proven designs. The reactor is not really the difficult piece of this DFMA nuclear mission, right? It's truly the deployment side, which I know Bryden Wood has done some very deep thinking about with Terra Praxis, for example. And the opportunity here is that you must design everything so that it can be built in a factory and then assembled easily on site. And that's what Aalo is really about. We say our product is not the reactor, it's the full plant. And for us, we've done a lot of customer feedback, sort of interviews, talking to my former employers and others. And there's this moment in time where data centers are being, because of the macro and sort of the transmission bottlenecks and the asynchronicity between data center planning and utility planning, they're being forced to move from just being able to procure power directly from a utility, not possible at the growth scale they need and the time scales they need, and having to think about what does it look like to go outside that box, right? And you can get lost in the list of opportunities there. Most folks will use phrases like behind the meter, but when you double click on what does behind the meter mean, you can end up talking about many, many different things. So Aalo really has done a lot of digging into what customers want and need. And when I say customers, I mean data centers in this example. And we've learned that they really want about a 50 megawatts, 50 electric Lego block that's copy and paste printable, multiple deployments at a single sort of data center campus that doesn't require much water, if any at all, and can be stood up on a power ramp curve that's predictable to grow with the data center campus. So that's what Aalo is doing, is we're bringing together these 10 megawatt electric reactors that can be factory built, shipped to site alongside a modular deployment system. We're bundling 5 of those reactors into what we call an Aalo pod, which is the true product at the end of the day. And each Aalo pod has one steam turbine generator that converts the heat from the 5 reactors into electricity. And this whole thing is, the building itself is about 2.5 acres. By the time you factor in, security and lay down and parking, et cetera, it's about 5 acres, 5.5 acres. So, playing that out, that's a very small fraction of land that's required compared to the data center. So it's an easy tack on to say, hey, we imagine a world where a data center campus that scales to a gigawatt plus, which is really, again, a cluster of 50 to 100, 150 megawatt buildings that are growing themselves, can bring with it its own power generation. I'm sure there's a number of listeners who immediately went to, yeah, but what are you going to do about power condition, availability, reliability, et cetera? That's also a part of the story, but we're really focused on the product of the pod being able to produce, high 9s of reliability, clean, firm power from the modular nuclear reactors. So modular approach, proven technology, modular construction, assembly. It's a platform with a system or a kit of parts, which I know is an echo of kind of how Bryden Wood and Terra Praxis have thought about it a bit. By the way, we think that Aalo's job is to stick to our core competencies. So I'm a big fan of open compute and things like that from the data center side, who seek standardization for the benefit of the broader supply chain to come together to achieve scale, and scale up's such a big part of what we want to accomplish. It's not about our first pod deployment or even our fifth pod deployment. We're really successful when we're able to produce about 100 of these reactors per year from our gigafactory, which is what we call it, because it'll be a true gigawatt per year that's being produced off the factory, and continue to ship those, deploy them on sort of a 2 to 3 month increment in clusters of 5. So the other piece of this that's maybe worth mentioning is we also took everything's about speed and scale up for us, not necessarily inventing some new science. We want to take what's ready. So we have pivoted to, or I should say selected, a fuel source that's widely available and proven today. That was a deliberate choice around speed and economics to bring real project execution. So when I bundle all this together, it means that in 2 years' time, we should be well underway and near reaching what we call criticality. So our first nuclear reactor should be coming online around the end of 2027. And because of the way we're doing it, we should be into commercial scale up by the end of the decade. Optimistically, our internal targets are 2029, may go to 2030, but in the nuclear world, 5 years out from commercial liftoff is a pretty aggressive push.
Yes, everything I've read has said that SMRs, small modular reactors, are 10, 20, 30 years away because of all the things that have to happen. I think that the difference in we talk a lot about sort of scale up, scale out. So whether you make a bigger and bigger facility or whether you do multiples of smaller increments, I think doing smaller increments and really doing that at scale, that's quite a different strategy, and that really does get you into the product space. Then you're talking about, as you say, deployments of hundreds of these things, where other people might be looking at to do 5 or 10 of those. So that's been quite an interesting. You must have done quite a lot to look at the sort of tipping point, and as you say, you then suddenly start to enable. I know in the Goldilocks, perhaps you can unpack the sort of Goldilocks suit, which I love that phrase, by the way, but it talks about gearing towards existing supply chains, using existing technology, as you say, not reinventing things you don't have to. And I think that potential speed to market is unlike any. No one else is talking about that sort of speed to market. There must be a massive advantage in being able to do that. Perhaps you can unpack the sort of Goldilocks soup a little bit and maybe talk about some of the blockers to this. I know regulatory approval will be one of the things you can't control, which will be controlling some of the timings around this adoption.
Yeah, I'd be happy to. And I think the first point to frame around this concept of Goldilocks soup is, if you talk to someone who's been looking at this sector for a while or sort of savvy about it, they'll ask, again, why now? And the key thing that really it was fuzzy at first to me, but it's crystal clear now for a couple of years, is when we say SMR, or small modular reactor, that's a market that really was defined before the data center boom is where it is today. And so that SMR deployment threshold or paradigm is really through a bulk power system, where you're taking yes, it's a small reactor in comparison to large nuclear reactors that we're accustomed to, but they're still quite large. I mean, these are 300 megawatts, et cetera, and they're still large projects. And while the reactors themselves have been somewhat modularized, they're not really modular systems for deployment. And so the paradigm, what I want to nail here is like the bulk power system, transmission and distribution, hub and spoke deployment model, that is set up for a different way of building. And then way over on the other end of the spectrum is this concept of micro reactors. So you sort of had SMRs over here, scaled down big stuff, and then you had micro reactors way over here saying we're going to go chase, diesel backup generators as an example, like remote communities, military sites, mining, and harsh environments, et cetera. And those both have a place, right? I don't want to undermine their value, and they've done a great job of honing in on their markets. What I want folks to sort of like contemplate is this middle market didn't exist before, and that was data center direct procurement. And that wedge has expanded rapidly. So being able to sort of start a company in the last few years, born out of that Marvel program I talked about from DOE, it is just sort of luck and timing in some ways, because you have a procurement model for nuclear power that just didn't exist before. And if I put myself back just for a second to be empathetic toward the technology companies and the data center folks that want to buy power, we would have much preferred to just stick with buying from the utilities. We'd like to be grid tied and just put in some backup power and achieve our 5 nines of reliability for power without having to be in that space. But ultimately, as I alluded to earlier, that's not the case anymore. And that contributes to this concept of Goldilocks soup, right? If the soup's too hot, you're doing really unnatural things that break the model and pull you into business models that don't make sense, and you're over investing in unproven technologies, and you're trying to force generation onto your site in ways that are sort of adversarial maybe to a utility, particularly in the US market where the AI data center boom is really leading. And if the soup's too cold, the utility companies aren't even getting the demand signal they require to think on a 10, 15-year horizon to contract an SMR plant or any other sort of form of large clean generation. So I do think that just from a market dynamics standpoint, you have the Goldilocks moment itself. The other thing that's worth mentioning is I just don't know of any other topic off the top of my head where both sides of the US political spectrum at least can agree. And what a phenomenal thing that for 2-3 years now, both sides of U.S. legislature have Congress have agreed on this and passed bipartisan bills related to nuclear, because the environmental side will say we need it for climate change purposes, and then the other side will say we need it for energy security purposes, and they both can be right, by the way. So that's kind of nice. And so the Department of Energy is leaning in. There's a New York Times broke a story a couple of days ago that by the time we publish this probably will be very old news, about the Trump administration contemplating an executive order around accelerating nuclear power deployment, which is pretty interesting. So the regulatory piece, what I'm getting at, is a really interesting shift in the Goldilocks soup, where things are changing very quickly for the betterment of creative thinking and new deployment models. A piece of my CV that I left out that's probably worth mentioning in this moment is before I was with the tech companies and before I was in the established energy sector, I did try my hand at a startup company. So this is my second startup, Aalo Atomics, in the energy space. And that one was in the hydropower space. And the reason I think it's worth mentioning is it shared some analogs to where we are today. The thinking was, we'll scale up through manufacturing, taking a large power generation system and making it more modular. We'll go about large regulatory shifts, because rivers are an interstate form of commerce in the United States, so they're regulated by the federal agency, which is unique. I think only hydropower and nuclear are regulated by a federal agency in the US. And furthermore, dams, so the large-scale version of this, are scary, are bad, have done poor things to the environment, fish migration, sediment transport, water rights issues. So when you come in with a new form of hydropower, which we were proposing to do, sort of run-of-river hydrokinetics that we could commercialize in these rivers that have already been disturbed for flood control and navigation purposes, like the Mississippi River that ran through my hometown, same mission statement, you run into an old way of licensing that doesn't apply to the new form of technology. And we were sort of on that mission when unconventional shale in the oil and gas space collapsed the price of gas in the US markets in particular. So with it also went the price of power, and our market fell out from the bottom of us while we were trying to sort of commercialize this new industry. So it's not my first go at something like this. And it does speak to how all the things in the Goldilocks soup need to come to the right temperature at the right time. And I do see that starting to come together. The final piece is the finance side. that I wanted to mention. The World Bank is lifting, or in the process of lifting, their ban on financing nuclear projects. U.S. banks have, in particular, have gotten a hold of it pretty well. We've seen some companies go public. Access to project finance is starting to be unlocked. The loan program office in the U.S. around the Department of Energy really is there to serve as this bridge between venture capital funding, which we're using today to deploy our first projects, and long-term project finance, which obviously wants high reliability and credibility in a project, right? So this valley of death in the financing side must be bridged, and we're starting to see more players in that space as well.
Yeah, so as you say, it's incredible. We talk about happy coincidences, and it's an incredible set of circumstance that seem to be coming together just at the right time. And yeah, I'll be using the phrase Goldilocks soup moving forward, I think. But so as a technological optimist, obviously you're focused on, and yeah, for very sensible reasons, you're focused on the data center market. I presume you must have one eye on the personal mission to saying, if we cracked it, then yeah, potentially the cost of the product drops, and this could really be a way of tackling the things that really drive you around energy poverty, and the broad scale adoption of this could be absolutely vast, couldn't it, if we get this right?
Yeah, absolutely. In fact, one of the things that I really appreciate about our chief technology officer and co-founder, Yasser Arafat, is, by the way, he comes from an interesting story himself. He's a non-US, originally Burma or Myanmar, depending on who you're speaking with, over to Bangladesh, and then ultimately the US. And so I like that Yasser keeps in mind himself growing up, having to study by candlelight with power interruptions and access to power. And he has this deep mission statement, probably even more ground zero for climate change would be Chittagong, the city where he's from in Bangladesh. So one of the things I deeply appreciate about Yasser's approach is he believes that, I talked about the Aalo pod being our product. He believes that the factory itself is a product, and that the factory must be repeatable at a relatively low predictable cost. And he's forcing himself and the team to leverage proven manufacturing technologies and supply chain parts. He likes to say there's no unobtainium in our supply chain. It's a lot of stainless steel and cement. And so the idea there is that we would be able to have this be a US export technology to appropriate countries where we could build more manufacturing plants and have a proven dispatchable deployment model that's highly repeatable. So the scale up to rest of the world should follow, certainly if I'm forecasting out within the next 10 years.
Yeah, which is, I mean, it's incredible ambition, but it's very much on your personal mission. Don't sell them the product, sell them the things that enables them to make the product and start to self-determine all the rest of it. So yeah, I think that's just a phenomenal ambition that you're on. So I'm just looking at the time. We probably have to park it there. There's probably lots more questions, but this has been fascinating. I think it's been the most into the greatest intersection of sort of a personal mission and a technology and a broad sense of doing the right thing. It's been your journey has been fascinating, and hopefully our listeners have found it as inspirational as I have. So thank you ever so much for joining us, Jon.
Jaimie, thanks for having me on and tolerating my long-winded responses. It's such a pleasure to chat with you, and I hope to continue to chat more offline.
It's been great. Thank you.